This is a very quick first video on parabolas part 4. There's going to be a second video that's much longer that you should also watch concerning this topic. So we're going to talk about an equation that looks like this. X minus 2 is equal to y minus 3 squared. And you might be asking, what the heck? Why is the y squared and not the x? This isn't my typical parabola. Well, no, indeed, it's actually a different kind of parabola that we haven't seen before. But the vertex is still going to be 2, 3, just like before. Whatever makes that x minus 2 side 0 and whatever makes the y minus 3 side 0. So that would be 2, 3. I'm going to graph that point. Now, I noticed that I'm going to be moving one by one in y, kind of independently of anything else that's happening. But as I move one by one, however much I move up or down by, I'm going to actually go over by the square of that, which means I'm going to kind of get this sideways looking parabola, right? For every 1 unit that I move in y, I square that, and that's how much I'm going to move in x. Okay, so I'm going to move positively in x, so I get this sideways parabola that's opening to the right. Let's suppose I have another parabola that has an equation y plus 3 is equal to negative 2 times y plus 1 squared. So here the vertex is whatever makes the x plus 3, 0, which is negative 3, and whatever makes the y plus 1 side 0, which is negative 1. So negative 3, negative 1 is right there. So again, I'm moving one by one in y this time, but squaring that and then doubling it and moving negatively in the x direction, right? Because I have negative 2 in front of it. So it's just like how we would move down if a was negative. Now, instead we're moving to the left if a is negative because I have a sideways parabola. So a sideways parabola is when I have y squared as opposed to x being squared. So I have a positive a that opens to the right and negative a opens to the left because I'm moving in the negative x direction, right? Because I square how much I move in y and then I'm kind of doubling it, right, after I square it. And then I'm going to, of course, move to the left because it's negative. So the standard form would be x minus h is equal to a times y minus k squared. We'll see more on that later and also in class. Suppose that we have y is greater than or equal to 2 times x plus 1 squared. So I'm going to graph this parabola. It obviously has this greater than or equal to sign, which we're going to have to figure out what that means. So the vertex of this parabola is going to be negative 1, 0, right? It's whatever makes the x plus 1 term 0 and whatever makes y 0. So it's going to be negative 1, 0, which I'll plot right there. And then this is just a standard up and down parabola where I'm moving over by 1, squaring that, and then doubling it, right, every time. So then I move over by 2, square it, and then double it. So I move up by 8, and I get this parabola that faces up. Now, it's greater than or equal to, which means I'm going to shade above, in the y direction, above the parabola. Okay, so it kind of ends up sort of inside the parabola. But if you kind of test any point outside of that shaded region, you'll realize that for every x coordinate, it's actually going to be less than the parabola's y coordinate. So anyway, you can try that out. Suppose I have another parabola that's x minus 11 is equal to y squared plus 6y. I have to complete the square, so 2 alpha is equal to 6, alpha is equal to 3, alpha squared is equal to 9. I add that to both sides, and then I get x minus 2 is less than x plus 3 squared. My vertex is 2, negative 3, so I plot that. And this is going to be a sideways parabola, right? I'm moving up 1 or down 1, right? And then that's going to be squared, so I'm going to be moving to the side 1, and then I'll move up or down 2, and then it'll be squared, so I'll move to the side 4, right? So I get the sideways parabola, and I'm going to shade to the left, right? Because all those x values to the left are actually smaller. They're less than the parabola. Good luck, have a great day, and watch the second part of this topic.